The Porsche 928 series will have some changes in the 1990 model year. An important introduction will be the Porsche locking differential named PSD. It's a new development installed for the first time in a motor car. Unlike the common mechanical locking differential in drive axles, the PSD is electronically controlled. With PSD, the 928 models prove technological leadership, especially in respect to driving safety. 3 examples. First, traction problems with conventional drive systems on differing surfaces. Asphalt left, gravel on the right. The right drive wheel spins during acceleration. The car hesitantly moves forward. In slow motion, the different speeds of the wheels can be clearly seen. The same situation as seen by computer graphics. During acceleration, the right rear wheel turns faster than the left wheel. In this case, the PSD calls on the ABS sensors to recognize differing wheel speeds. The process is seen through the microscope. During acceleration, the right drive wheel spins. The sensors register this and signal the PSD electronic control system. PSD, the Porsche locking differential, locks as needed up to 100%. This function is limited to speeds of 30 kilometers per hour in order to prevent uncontrolled maneuvers from happening. A look in slow motion clearly shows that despite the Porsche 928's high performance on differing surfaces, the wheels quickly reach equal speeds. Mastering road dynamic situations is one of the traditional strengths of Porsche sports cars. Road dynamics for the customer's benefit. That includes the mastering of cornering with high transverse acceleration, here being deliberately exceeded at the Weissach test grounds. Example 2. A Porsche 928 in the same situation with PSD, retaining its holding stability. Again the difference, without PSD, with PSD. Even the subjective camera clearly shows the advantage, first without, and now the same test with PSD. The computer graphic shows that in curves, the inside drive wheel tends to spin. Forward movement more or less stops. The vehicle spins out. With PSD, a precisely determined locking moment takes effect as required by road dynamics. The moment is determined by an electronic calculation of cornering speed, curve radius, and transverse acceleration. The computer graphic again illustrates the situation. The inside wheel tends to spin, which can lead to an unstable handling situation. The wheel and transverse acceleration sensors sound the alarm. The PSD control unit analyzes the situation. Control impulses are sent out, which, with hydraulic aid in the locking differential, introduce the exact degree of locking to deal with the situation. Even under the microscope, a variable locking factor from 0 to 100% is introduced and controlled as the situation requires. This beautiful landscape may be deceptive, especially in mountainous, twisting terrain. The road dynamic demands made on a driver and car are especially great. It's a rapid combination of curves, short bursts of acceleration, and hairpin turns. Example 3. During load change reactions, stepping on the gas and braking, a tendency towards oversteer is not unusual. In this situation, a Porsche with PSD, a locking moment is immediately introduced to prevent oversteer. The sensor again signals the tendency towards differing wheel speeds. The control system considers values for transverse acceleration, right or left curve recognition, and the momentary wheel behavior, for example, acceleration or deceleration. And in this case also, the PSD reacts with an adjustment of wheel speed. The variable locking moment is again reduced in stages, exactly when the road dynamic situation requires it. The system reacts in thousandths of a second. With the 1990 model year, Porsche is introducing new technology to strengthen its leadership in exclusive sports cars. At the same time, Porsche drivers have the opportunity, in safety, of dealing with road dynamic problems with the means of the most modern technology.